Abe, welcome. Abe, you are the founder and CEO of Superconductive, the company behind the Great Expectations open source project and open source tool for data quality, including data testing, documentation, and profiling. And previously, you were the chief data officer at Aspire Health and the first data scientist at Jawbone, which is a very cool background. So to jump right into it, what is data quality and why does it matter?
That is a huge question. And I think maybe the most useful thing—
10 seconds or less.
In 10 seconds. So I think it's actually really interesting to break that out between what does that mean for coders and developers versus what does it mean for the rest of the world? Because data quality has kind of bubbled up to the point where it's a C-level issue for a lot of companies. And at the same time, it's something that you deal with in a very granular way if you're a data scientist or data engineer. And as you said, that's my background, hands-on keyboard work in IoT, in health and wellness, in regulated healthcare. So if you're an engineer, I think you think of it as testing, right? It's assertions about data to make sure that stuff that worked last week continues to work, even when your upstream data partners push new data that, it better be new. It's not interesting, right? The whole point of data is it changes all the time, but there are certain characteristics of data that you want to be invariant. And so being able to know what to expect there is really helpful. If you're in the engineering world, I think you can give it this very precise technical definition around invariance in data. If you go outside the engineering world, there are a whole lot of people who have a stake in how data works, but they often have a hard time articulating exactly what is it that needs to be right, what is quality versus not quality. And I actually think that is the source of a whole lot of really interesting and powerful conversations, translating from those kind of very important, but often poorly articulated business concerns. When I say poorly articulated, what I really mean is not precisely technically articulated, right? It's expresses a real thing, but not necessarily in a way that's repeatable and can be taken to the code itself.
Yeah. And what would be an example of a business problem that derives from a data quality issue?
Yeah, so I think churn is a really good one to go to. So if you say problem, you can approach that on a couple levels, but the classic problem is the dashboard that breaks, right? So, last week it said that our churn rate was X, and this week it's saying that our churn rate is 3X. I'm pretty sure that the product didn't break that badly. So it's probably something in our data pipelines or the way we're measuring or observing, what's going on there. When we used to go to conferences before the world shut down, I'd often ask, who here has a story about the time when the dashboard broke? And people will sort of hesitantly raise their hand because nobody wants to admit it. But in my experience, almost every data scientist, almost every data analyst has a story about the time that the dashboard broke. And it sucked because there were other people who, were angry at the data team, and then you've got to go fix it. So, yeah, that. Those are the sorts of pain points that we're trying to prevent. Getting to the point where if the dashboard, and the truth is, you can't always completely prevent the dashboard from breaking because it might be because of upstream data that you don't control. But at the very least, you want to know about it before your stakeholders know about it, so that as a data team, you can get ahead of the issue. And of course, you can resolve things faster and hopefully have fewer bugs like that.
So why do those issues occur at a very simplistic level? What's the range of things that tend to go bad, leading to the quality issue?
It's an enormous range of things. I think the way I would describe it is actually to kind of pick up on Nick's language a little bit. He talked about how 80-90% of time spent by data scientists, data engineers is quote unquote data cleaning. When you look at what's happening in that data cleaning process, people are taking raw data, and raw means somebody else generated it, and you often don't know exactly where it came from. So in the data cleaning process, you're trying to form a mental model of, okay, where did this data come from? And therefore, what should I do with it in order to make it appropriate for my use case? And so these are decisions like, oh, maybe I'm going to drop outliers, or I'm only going to pay attention to certain columns, or I'm going to say that certain events are good and certain events are bad, or lots and lots of little decisions. And when you look at kind of the work that goes into data science and data engineering, a huge amount of it is just making those very small granular decisions about how you interpret this, lump of bits that came to you and what you believe that means about the upstream world. And now, any time when one of those decisions changes, either in your pipeline or because somebody upstream is doing something different, that could break things downstream. So, for example, when I was working in healthcare, we did integrations with insurance companies, and we had an insurance provider that would send us data where there was a gender column. And when we originally got the data, 1 meant male and 2 meant female. And so, the whole column was filled with 1s and 2s. We built machine learning models on that. We did a whole bunch of things with it because, gender is an important predictor of all kinds of healthcare outcomes. And then one day, we got the same data, except that the gender column contained 1s, 2s, 4s, and 9s. And if we had continued to run the same algorithms and the same analytics on it, we'd have gotten absolutely horrible answers. And horrible in the sense that most of our pipelines wouldn't have broken. They still would have executed, they still would have made predictions, but they would have been completely bogus predictions because what is a 9x female? I don't know what that means. So come to find out, what had happened is they had changed their upstream coding, and they were allowing their patients now to say, I don't want to assign myself a gender, or I prefer not to answer. Or excuse me, 4 was, I don't want to assign myself a binary gender. So it's male, female, other, or choose not to respond. And in order to kind of do the right thing with the data, you have to understand those micro decisions that this upstream team had made about what the gender column means.
Mm-hmm. There seems to be different types of approach to data quality in the market. Can you maybe talk about that? What are the different ways to sort of identify or address data quality, and then sort of what works and what doesn't?
Mm-hmm. That's also a really interesting question. I'm trying to figure out how to summarize a lot of things. I think kind of the big axis that I see is we've taken a very rules-based approach in the sense of declaring exactly what you expect of data in very fine-grained detail. There's also the possibility to do more kind of anomaly detection and automated inference of what goes into the data. And to be clear, we also do some of that. I think the main difference is, what is the developer experience around that? And not just developer, but for all of the people who touch data, how much ability do you have to kind of understand the rules? Frankly, I'm pretty skeptical of the anomaly detection approach, because if you think about data quality as kind of a testing problem, why is it that software engineers need tests to begin with? You need tests because they make tacit knowledge explicit. They make it very clear what the system is intended to do. So as tempting as it is to do anomaly detection on data, it can often shoot you in the foot, because now you have another system that kind of interprets the data in its own ways, it's a black box, and that black boxiness actually introduces another source of potential tacit knowledge in the system that's hard for you to interpret. Mm-hmm. So we've taken sort of a slower road on what we call data profilers, but being able to build tools that allow you to, the way we think of it is building checklists of questions that you can delegate the asking of to the computer.
Great. So let's dive into this. So again, the company is Superconductive. The open source project is Great Expectation. So you want to maybe define what an expectation is very much to this point in layman's terms.
Sure, and we've sort of been talking around it a little bit, but
yes.
So an expectation is a declarative statement about what the data should look like at a certain point in your data pipeline. So if you're in a DAX,
meaning your data should. What's an example a state?
So super simple things would be things like when this CSV gets into your SFTP server, it should have these columns. Or when you ingest this data into your Snowflake data warehouse, the columns the values in this column should be integers, and they should fall between 1 and 10 at least 90% of the time. Maybe we tolerate some small percentage of outliers.
So I'm an engineer, and you mentioned about like embedding people's knowledge. So like I'm an engineer, like I work with a business person or a data person, and like we know that this is what the format should look like. Therefore, we're going to create this rule and say if it doesn't look like this, then we're going to declare it as an expectation, and if that doesn't match, then what happens? I get an alert, or like what's the next step?
So that's up to you. The Great Expectations framework is pretty open-ended there. What most people do is some combination of an alert through Slack or email or PagerDuty, kind of your tool of choice there. And then also generating a report that goes into a static data documentation site that says this slice of the data at this point in time passed, all 110 checks passed, or, now I've got to do math, 102 passed, but these 8 failed. And here's some examples of failing rows so that you can go back and start to do root cause analysis and figure out where it went wrong.
Great. And then so you have a library of expectations that like different people can collaborate on, and you can add rules, remove rules. Is that how it works?
Yeah, that's exactly right. And just to go a little bit deeper, you said that expectations define kind of the schema of data. And I just want to emphasize, yes, you can do schema for, especially if you're in a world like CSV files where the schema itself isn't rigidly defined, then having that is very helpful. Even in other places, like within typed data frames in Spark, or your choice of data warehouses, being able to do sets, ranges, regular expressions, distributions, correlations, things like that start to be really valuable, because you get beyond the kind of just schema into the content and the texture of the data.
Yep. And then there is a concept of extensibility for the assertions. What does that mean?
It means that every one of these expectations is its own little module. And over time, we actually expect for a lot of these to be built. One of the things that we're asked about most frequently is, hey, can we extend the library of great expectations to do geographic data? So expect point to be within region. Or time series data, expect trend to be increasing by X%. We've done a bunch of work to get the core of the library in good shape. And one of the things that we're really excited to do now that we're through our Series A round is kind of resource better collaboration with the community to build out that library.
Great. And to continue diving into the product, so there is the concept of tests and human readable documentation. There is a concept of data profiling, which you started alluding to, and a concept of data validation. I'd love for you to go through those 3 different things and explain what they are.
Sure. I think data validation is the one that most people think of first. It's being able to monitor data as it flows through a pipeline to verify that it still matches expectations. I'll say parenthetically, there's also a kind of a Git flow version of this where you change the code and you want to verify that tests still pass. Both of those workflows are pretty similar. You just need slightly different fixtures and infrastructure for them. So data validation is, does my data look right? Data documentation is a thing that we consider a really important part of the project, and frankly, a technology that I don't think anybody else has invested deeply in building. It's one of the things that we think, as Great Expectations becomes this shared open standard for data quality, it's a place where I think we'll add a lot of value to the data ecosystem. So the notion is all of your tests are expressed in this declarative language, which engineers, of course, can work with. It's JSON, it's Python APIs, ties to SQL. But for all the other data stakeholders in an organization, people who don't write code, but still very much have important domain knowledge and need a say in how data works, it's really helpful to be able to compile those tests directly into reports, data dictionaries, static data documentation, maybe plug it into a metadata framework or a data catalog. what we're seeing is that allows kind of the structuring and the kind of development of data to not just be a narrow engineering concern, but to be something where the whole organization has a stake and has a very clean way of collaborating. Because unlike the classic outdated data wiki that most teams have lived with in the past, with Great Expectations, as long as you're running your tests, you know that your documentation actually reflects the current state of the data, which is kind of a guarantee that's very hard to get any other way.
And looking at your customer list, which is impressive, you seem to have companies that are, both like growth level startups like Calm and Komodo Health, but now public companies like Vimeo, or like more traditional like Fortune 1000 companies like Heineken. Like presumably those are like pretty different types of data stacks, or maybe not. I don't know. Does the product work with like any kind of environment, or is it particularly appropriate for like a certain type of customers?
So, I mean, I would love to say it works everywhere. The truth is, there's some things that are fully supported and some things that are kind of more experimental. So, for example, Dask. We know that there are a number of companies that have deployed and used Great Expectations on Dask. There are a lot of Prefect users, for example, who are using both tools together. And we don't currently, as part of our testing infrastructure, run all of the checks against Dask. So it's possible that at some point, we'd accidentally break something. Now, that's a thing that we plan to fix eventually. But so I just want to point to this gray area of places where the tool is being used, but we as maintainers of the open source project haven't fully shouldered the burden yet of maintaining it. Now, that said, we've always believed that it was very important to have kind of a global view into what is going on in your data. And I mean, as we've heard from Nick and also from Deveris, like data engineering is like a multi-application, like like complicated stack world. And so having tests that can travel with you across that is important. The primary backends that Great Expectations runs on are Python Pandas, which allows you to bring in a lot of notebooks, a lot of machine learning type workflows. We also do Spark data frames, and then SQL through SQL Alchemy, which also implies a whole slew of different SQL dialects. So the kind of guarantee is any given expectation will execute in any of those environments, and it'll execute consistently. So you know that if your data kind of moves from one system to the next, if you want to run the same tests, your test can follow it. It also provides this interesting continuity across time. If you're living, for example, we've seen quite a few teams that are migrating from one data warehouse to another. Like lately, it's often Snowflake. And being able to test your data prior to the migration and then ensure that the same invariants work after you're on a different backend, that's pretty cool. It's a technology that, again, is pretty hard to get any other way.
Interesting. There is a type of events that you guys do on the open source front that you call community roadmap. What does that mean, and how do you leverage open source community to build your roadmap?
So this is actually a new thing, and we're doing it for the first time next week.
Oh, great. Okay. What day is it? Like, it's great for a plug.
Yeah, let me check my calendar so I give everybody exactly the right time. Yeah, so it's a week from today, actually close to the same time. It's at 3 p.m. Pacific.
Great.
We picked that time so that it would work for most US time zones with a little bit of a stretch. But
people can find the information on superconductive something.
Yeah, so if you go to greatexpectations.io, you can find it.
Okay,
let me just grab the link just so there's no slippage here, because it's not right front and center there. We'll have to go into the blog.
Okay. Anyway, while you do that, so how's that going to work?
So, I mean, our goal for the open source project is really to create a shared open standard around data quality. And to do that, we need input from the community. Like, we don't believe that it is a thing that we should solely govern. We think it's important for Superconductive as an entity to be able to kind of bring together ideas, help prioritize, help move things forward. So there's sort of a PMing role to be done there. But as we build integrations to more backends, as we tie into additional systems that you can kick off actions in post-validation, building more expectations, building more profilers, there's actually a lot of surface area there. And I think we're unusual as an open source project in the sense that the same people who use it can also contribute directly to it. It's not the case for things like Docker, say, where it's sort of an infrastructure layer that a lot of people use, but it's at a lower level of abstraction than most of the developers would develop in. Great Expectations is actually a place where lots of people want to develop custom expectations and extend that library. And so we want to make that as easy as possible. And community roadmap meetings are a way of kind of facilitating that. And like I said, we're doing this for the first time next week. We'll be figuring out the format a little bit as we go along. And we have a Slack community that has several thousand people in it at this point. So we already have, I think, a pretty decent sense of where the main majority is going. I'm going to paste the blog post into the chat so that people have that link if they just want to link directly there. We'd love to see people there. It'd be awesome.
Wonderful. Thanks for the link. So we've talked a lot about the open source project. Let's talk a little bit about the commercial company, Superconductive, and then Great Expectations Cloud. What does that, or what will that do?
So Superconductive is the formal corporate entity behind the company. We actually started in healthcare data analytics and kind of deliberately pivoted the company to open source about 2 years ago now, when Great Expectations started to just really take on a life of its own. And it became obvious that there was something really interesting happening around data quality. So just a little bit of backstory so everybody understands why the names are different. Great Expectations Cloud is the SaaS offering that we are building on top of open source Great Expectations. I'm going to be slightly less cagey than Nick here, although we haven't formally unveiled and kind of like shown everybody what it can do. But we're currently working with a small number of design partners on it. The way that we think of it is it's a collaboration layer that sits on top of the open source project. So we've have committed, will always commit to keeping everything that's in open source Great Expectations open. And there are a bunch of things that you can do once you have all the power of SaaS at your disposal, and it's not just a Python library, that will lend themselves to much better data collaboration.
Very good. And so when is that happening? What is that like roughly?
So we're working with design partners now, and if there are people in the audience who want to get on that list, we're keeping it pretty limited at the moment, but we'll be expanding soon. If you go to the website, there actually is a link for Great Expectations Cloud. It's buried. We're not deliberately driving a lot of traffic there, but if you're interested in being an early design partner, we'd love to talk.
All right, very good. All right, so just to close, as we are at the end of time, would love to do this a couple of rapid fire bonus questions as well. So outside of Great Expectations, what's a data tool or project or a company that you just think is very cool, whether that's something that's famous or something that's just emerging? Yeah,
so one, and Nick may beat me up for this because I know philosophically he does not love this approach, but Hasura. I love Hasura as a prototyping tool. I think being able to just...
Can you spell this for the audience?
Hasura. And basically it's sort of like, it's just add water GraphQL for Postgres. So if you've got a Postgres database, then you can point Hasura at it and extremely quickly spin up a GraphQL API for it. And subscriptions, queries, mutations, like you get all of those things. It's all code gen, so there are some limits to what you can do with that. And I don't know that I would swear by it as an actual production system, but as somebody who likes to prototype quickly, it's pretty beautiful to be able to have your Postgres schema immediately flow through to an API. The other one that I'd point to that I haven't used deeply myself, but I just think is a thing that the world really needs is SQL Fluff, SQL FLUFF. It's a linter for SQL, and I'm just kind of shocked that we have got to 2021 without there being a good, well-defined SQL linter. So anyway, it's cool. People behind it are cool people.
Yeah, very cool. Very interesting. And then last question, what are some of the data learning resources that you find interesting or that you would recommend to people listening so that they can continue learning about the space, whether a podcast, newsletter, or book, or whatever?
Yeah, we've heard a lot of them already. So Locally Optimistic, I think, is an amazing community. Software Engineering Daily. Two that I didn't hear specifically mentioned that I follow pretty avidly. Randy Au, Counting Stuff. It's just him kind of weekly blogging stuff that he finds interesting in data science, data engineering. It's very thoughtful. I really like his perspective. And then Amplify, Sarah Catanzaro has Projects to Know. She does a good job of rounding up, especially kind of the cutting edge of machine learning papers, and then a good smattering of stuff that's going on in open source. I find that she goes, I think a lot of the stuff there is not at the commercialization phase yet, which is partly what makes it interesting. It's a little bit earlier in the idea pipeline.
Very good. No, those two are excellent recommendations and resources. Cool. Well, that was awesome. Super interesting, and I think nicely digestible for folks. So really appreciate it. You're coming on and telling us all about what you've been doing, and I've said this a few times tonight, but this is another project that if you're in the data world, everybody talks about Great Expectations all the time. So clearly you've done something very right, and very excited to see how that develops over the next months and years. Yeah,
thank you. And I'll just say, being at the middle of an open source community like this I don't think I knew it at the time, but it's my dream job. It is so fun to collaborate with smart people and just build a thing in the open that should exist. So yeah, thanks for having me on to talk about it more.
That's great. Thank you so much, Abe. Really appreciate it.